All right, here are solutions to perfect problem 3 for Math 111. Your first thing you're asked to do is sketch this function right here, and I did that down here. Just use your graphing calculator, nothing too exciting there. Step 2 is a little bit more. Ask you to find use the minimum and maximum functions on your graphing calculator, which you can get to under Calc, the Calc menu. It's in there, and if you use those, you can figure out these 3 points that I have labeled here. This guy up here, down here, and over here. Those will be useful later in the problem. So got that. And now we can start doing some stuff. Let's see. The first part says, maybe I should switch colors. Using your sketch, so using this, estimate f of 1. So, okay, f of 1 is saying what is the output when 1 is the input. In other words, what is the height corresponding with this x value right here? Kind of hard to tell, especially when you can't draw straight lines. But whatever this height right here is my answer. So I don't know, on my graph it looks like maybe -8 or so. So f of 1 is approximately -8. But I don't know, -6, 5, 9, any of those could be right depending on how your graph looks in this area. I'm not asking you to calculate an exact value. I want you to look at your graph and understand that the height of the graph when x equals 1 gives you f of 1. So, okay. Using your sketch, estimate all solutions to this equation. Okay, so I have all this mess equals 1. All this mess is exactly our function. So really what this is asking here is, when is our function equal to 1? In other words, find all x. Maybe I could write that up here. This is really just saying find all x so that f of x, which is all this mess on the left-hand side, equals 1, what I have on the right-hand side. So you can figure that out by drawing a vertical line when the height is equal to 1. Something like that. And then look for intersections. So it looks like we got an intersection right here, right here, right there, and right there. So what I would say is, I guess to answer the question, solutions to 1/6 x to the 4th plus 5/6 x cubed minus 2x squared minus 6x plus 1 equals 1 are approximately, this keyword here, when x equals, okay, what's the input here? Well, let's see, this is -5, this is -6, so I don't know, maybe -5.5. Another one here. Let's see, here is -1, -2. Looks like it's pretty close to -2. Maybe I'll call it, yeah, why not, -2? Who cares? Then you got another one here. It looks like it happens right at 0. I think that one actually does happen at 0. You can kind of see that if you make all the x's 0. We just have 1 equals 1. And the last one, 1, 2. It looks like it's pretty close to 3 here. So we'll say 3. And it may be worth putting in a note here. Your answers may vary. That's for this guy and for this guy. What's more important is that your answers match up with the graph. That's really the idea behind all this. Okay, so we got that part done. Put a little check mark next to it in light green. And so the final question here, I don't think I've used purple much yet. Using your sketch, express the range of this thing in interval notation. Okay. The range of this function is all the possible outputs. So it looks like I can have outputs anywhere. This looks like the lowest point, which happens at -20.21. So we have some point down there. And then all of these outputs work. And it looks like it goes on towards infinity, so I'll put a little arrow at the top, because we got these arrows going up. So we can get any output as big as we want. So what I would say is the range goes from negative 20.21, this value I have figured out right here, the y value, all the way up to infinity. Something like that. And I guess that's the last question. So that's the end of this problem.